Hello viewers, welcome to the Champion Tutors Academy YouTube channel. In this discussion, still looking at differential calculus. We have a problem where we have the function of y which is equal to natural log of 2x squared plus 3, and we are then taught to find the second derivative from this function. So what we're going to do is we're first going to find the first derivative of this natural log function, and then after finding the first derivative, we're then going to find the second gradient function of the same given function of y. So here we have the function of y which is equal to natural log of open brackets 2x squared plus 3, like that. Now what it is that here it's the same as saying that we have y which is equal to the natural log of a function. So this is a function of which you can label it as f of x, or if you want you can label it as u. Now in this case, since we've labeled it as f of x, meaning that if you have something like this, finding the derivative of y with respect to x of a natural log in this manner, what you're going to do is you're going to find the derivative of this function with respect to x, like that, so it will be f prime of x. Then after this is found, we're going to divide with the function f of x the way it is, which is in here. So this is the same knowledge we're going to apply with the problem that we have here. So we're going to say that dy dx will be equal to, so we're going to find f prime of x of this one. So differentiating this one using the power, we're going to get 4x, like that. Then after we found our 4x, we're then going to divide with the function itself the way it is, which is 2x squared plus 3. So if you look at this one, this is our first derivative. Now the problem is not telling us to find the first derivative, but rather it's telling us to find the second derivative. So what we're going to do is we're then going to differentiate this gradient function again for us to come up with the second gradient function. So we're going to say that second derivative, which is this, will be equal to, now when you differentiate this one, now if you look at this function, this is 4x dividing with 2x squared plus 3. So if you look at the manner of this function, we have a numerator and a denominator, meaning that it is a function which is y as a quotient. So meaning that we are going to use a quotient rule for us to find the second gradient function. Now the second derivative, find the gradient function using the quotient rule. I'm supposed to say v du over dx minus u dv over dx divided by v squared. So from what we have here, we're going to say, we're going to let the one which is on top to be our function of u. So we're going to say let u to be equal to 4x, and our v will be the function which is down here, which is v will be equal to 2x squared plus 3. So from there, we're then going to find du dx. So du dx will be equal to 4, and dv dx will be equal to 2 times 2 give us 4x, like that. So this is our derivative for v. So from there, what we do is we're going to say that dy dx, from what we have here, we're going to multiply the function of v, which is this one. So we're going to say 2x squared plus 3 to multiply with the derivative of u, which is a 4. We're going to say minus the function of v, which is 4x, to multiply with the gradient function of v, which is 4x also. Then we divide throughout by v squared, which is this one, 2x squared plus 3, like that. Now this has to be squared. So because of space, I'm going to take this information up there. So it will be 4 multiplied by 2x squared. I'm going to get 8x. I'm going to get 8x squared plus, when I multiply 4 by 3, I'm going to get 12. Then I'm going to say minus 4x times 4x, I'm going to get 16x squared divided by what I have done there, which is 2x squared plus 3 squared, like that. So from there, if I look at the function that I have there, I have something that is common in each and every term, which is a 4. So this 4 will be factored out. So I'm going to simply have something like, when I wrap this part, I'm going to have 4 into 8. I'm going first to factor out the 4, then I have 2x squared plus 4 into 12 will give me 3 minus 4 into 16. I'm going to get a 4x squared. Then from there I will divide by 2x squared plus 3. Then this will be squared, like that. Now, since I still need to use the lower part, I'm going to say that I'm going to write my 4, then I'll open the bracket. So here I have some common terms, so which is 2x squared minus 4x squared plus 3 over 2x squared plus 3. Now this is squared. So this will simply give me 4 outside. Then 2x squared minus 4x squared, I'm going to get a negative 2x squared plus 3, like that. Then I'm going to say over 2x squared plus 3. Now this is squared. So after this is done, this is now my gradient function of this. So this is my second derivative. So this is the same answer. I'm going to substitute where there is the second derivative. So meaning that the second derivative, or d²y over dx² of this function, is simply equal to 4 negative 2x, or which can still be written as 3 minus 2x squared over 2x squared plus 3 raised to the power 2. So this is the second gradient function of this function of y equal to natural log of 2x squared plus 3. Hence solved.